College Algebra, Chapter 4, Section 4, Quadratic Models from Data. So, first of all, Objective 1. Solve applied problems involving quadratic functions. Well, this is going to be sort of really part of Objective 2. Because Objective 2 is using a graphing utility. Find the best fit. I guess they call it the curve of best fit. So let's go to a problem, page 311, number 8. The enclosing a rectangular field. Beth has 3,000 feet of fencing available to enclose a rectangular field. Express the area A of the rectangle as a function of x, where x is the length of the rectangle. And then for what value of x is the area the largest, what is the maximum area? So if you were doing this, I guess, this is number 8, page 311. And the picture is a good place to start. It's a rectangular field. They want the length x. If you have 3,000 feet, then both of these will be x of the rectangle. And the 3,000 minus 2x's is what's left for these other sides. But you can't put 3,000 minus 2x on both sides. You have to put half of that, right? So each of these are 1,500 minus x. And that's how you express this rectangle. The area, which is the length times the width, the area in terms of x, is the length x times the width, 1,500 minus x. So that's the area. You could, if you wanted to, multiply that out. It's a negative x squared plus 1,500x. That's the area. That's part A. Part B, what x maximizes A? Well, the area, I guess, not the little a. So if we look at that, remember, a maximum or a minimum occurs at the vertex. Because this leading coefficient is negative, this vertex, or this parabola, opens down, and the vertex will be the maximum. Remember, the vertex is a negative b over 2a when it's written in this form, and then plug that in to get y, or in this case, the area. So a negative b over 2a, this negative 1,500 over negative 2. Plug it in to get y. So this is really 750. 750 is the x-coordinate. Plug in a 750. And you get 750 times, that's a 750, well, because this is 1,500 minus 750, it's times 750. And if you multiply that out, you get 500,062, 500. 562, 500. So that is the y. Now, they're asking for x, what x maximizes, 750. So for part B, what x maximizes this, that's the 750. Part C, what is the maximum value? So part C is the 562, 500. That's the area, square feet. Remember, the vertex is where a maximum minimum occurs. The x-coordinate is where, and the y-coordinate is how much. So it occurs at 750, and it's 562,500 square feet. Okay, how about number 30? This is on page, a couple pages down the road, 313. Miles per gallon. An engineer collects data showing the speed, S, of a Ford Taurus and its average miles per gallon, M. See the table. This is on page 313. They want you to draw a scatter diagram, comment on the type of relationship that may exist. The quadratic function best fits. They give you one. We're going to have it figure it out for our calculator, because I'll probably have you do that on the test. Use that function to predict the miles per gallon for a speed of 63 miles per hour, and then verify that the function given is the quadratic function that best fits. And draw that function on the scatter plot. So, this is the data, and I'm going to stop it here so I can get the data in here. So here's the data. We're going to put that in the calculator, and I'll go through those steps here. You enter the data, that's under stat edit. Then you set up the stat plot. Zoom stat, that's an easy way of getting the screen. I guess this is the setup screen. Then you find the regression equation going into stat calc. So let's do that. Here's my calculator. Yours looks similar, maybe newer. Get out of this, second quit, clear this off. Now you go to stat and edit. I'm going to clear out L1 and L2 to the name, clear, enter. To the name, clear, enter. Here's where we put in the data. 30, 35, 40 twice, 45, 50, 55, 60, 65 twice, and 70. Now let's put in the corresponding. It's 18, 20, 23, 25 twice, 28, 30, 29, 26, and 25 twice. Should come out the same. If they don't, better go and check your data. It's not bad to check this anyway, just to make sure that you haven't put anything in sort of crazy like a 1 instead of a 21 or something like that. Okay, so that's entering the data. Setting up stat plot is second y equals. Now if you've set this up before, it may be all ready to go. To make sure it's highlighted on the scatter plot, L1 and L2, and I use the box, so it's ready to go. And then a quick way to get the window is the zoom number 9 zoom stat. Now you're saying, well, what is all this extra stuff here? And this stuff peeking down below. Well, if you look at y equals, it's got all this from another problem, and that should give us a clean graph here. Remember, these two are for the 25 and 25 and another 25 and 25. That can happen. You're not going to hit every single one of those. How do you get the appropriate regression equation, stat, and calc, and go down. Oh, by the way, this looks like, I guess, an upside down quadratic. You could fit this with other things, a cubic, a quartic, maybe even a sine curve. But we're going to use quadratics because that's what this section's all about. So, stat, calc. Now go down to quadreg. We're going to use list 1 and list 2, or L1 and L2 for the X list and the Y list. And then we're going to store the regression equation in the vars, y vars, function y1. Press enter. And when you see this, these are the coefficients A, B, C, and then R squared tells you this fits about 89%. Those 2 points, 25, 25, and 25, 25, price throws it off. But let's take a look at this equation and the one they give you in the text. For the one in the text, they say it should be a negative 0.017 s squared. Negative 0.017, and I guess that works here. Plus 1.93s, 1.93, yep. And then the minus 25.34, 25.34. So this matches what they've got, at least to the first 2 decimal places. I guess this 3 decimal places for A, but 2 for the rest. So this is also placed in y equals, and it gives you all those decimal places. If you want to graph it to see it, this is what the graph looks like. That's what's going to approximate it best, taking all the data into account. So, draw a scatter plot. We've done that. Oh, I might want to mention this. When I ask you to do a scatter plot, probably I'm going to have you do it not really accurate. I'm going to have you do some things like this that you'll see from your calculator. So that I can see that at least you did it on your calculator. And you'll have it so it won't disappear every time you click on the screen. Use this to determine the speed that maximizes miles per gallon. Okay, in order to maximize it, we need this top point. How do you find that? Well, we do a second trace and go to maximum, number 4. Now, y1 has got our equation in it. We're going to do left bound, which I guess is good right there. Press enter. Go to the right of that peak, someplace over here, and press enter. For the guess, I'm going to get to the middle of what I think that peak is and press enter. And it tells me that when x is 55.378, we'll say, then y will be 28.227. So what does that mean? First of all, for part B, use this function to determine the speed that maximizes miles per gallon. The speed that maximizes miles per gallon is 55.378. Use the function to predict the miles per gallon for a speed of 63. Okay, how do we figure out the 63 on here? Once again, do second calc. And this value, number 1, allows you to put in x. If x is 63 miles per hour, that's your speed, then it'll find the y value. 27.212 is the miles per gallon for 63 on this graph. So that's the answer, 27.212 212 for part B. So part A, let's see. This is part A. Draw the scatter plot. Part B is, what's the maximum, I guess? What did we say that was? 55.378 miles per hour. Part C, at 63 miles per hour, you get the 27.212. So you get 27.212 miles per gallon. Okay. And part D is use of the graphing utility. We've already done that. To match the function. Part E, with the graphing utility, then we're going to approximate this. So you can approximate that. Does this make sense? You think you can do these? These are sort of fun, pretty neat. You can do this for a lot of data, especially data for your science courses, to try to figure out what fits. And of course, if it's supposed to be linear, then you got to use that linear regression. But if they say it could be quadratic or cubic, you can use that also. Okay, we'll see you next section.